Hello viewers, today in this part of the program we are going to discuss about the insolation, temperature, evaporation and their different aspects. We will discuss about the evaporation, measurement of the evaporation, measurement of temperature, then measurement of solar radiation. We will learn about the different instruments which are used for the measurement of the different aspects of the temperature. Now, first is about the solar insolation. We know that sun is the sole source of the insolation. So first we have to learn about the solar insolation. Solar insolation, the heat energy received from the sun is known as solar insolation. While radiation, it is the transfer of heat energy in the form of electromagnetic waves with the speed of light is known as radiation, and generally radiation comes at the speed of the light, that is 3 into 10 raised to 5 kilometer per second. Now we know that radiation comes in the form of electromagnetic waves. The electromagnetic spectrum consists of the wavelength that is less than 10 raised to minus 9 nanometer, that is gamma rays, to the 10 raised to 15 nanometer, that is electric waves. Now, to understand the solar radiation, it is very important to learn about the electromagnetic waves, because solar radiation comes in the form of these waves. Now next is the radiation receipt on the Earth's surface. The solar constant is a measure of the rate at which solar wave radiation is received at the top of the atmosphere on a unit surface per unit time at the Earth's mean distance from the Sun. The value of the solar constant is 1350 to 1400 watts per square meter, and roughly it comes to 1370 watts per square meter or 1.94 calorie per square centimeter per minute. Through this particular picture we can see that there is a sun, and sun is the sole source of the radiation, and short wave radiation, they are being emitted from the sun, and their wavelength is around 0.515 to the 0.4 micron, and it is coming on the Earth's surface, that is known as the solar constant, and value is 1.94 calorie per square centimeter per minute. But you see that when from after coming on the Earth's surface, when the terrestrial radiation goes back to the sky, they are called as the long wave radiation. So in this part we have covered that radiation are coming on the Earth's surface, they are being returned to the sky again, and they are called as the long wave radiation. Now global solar radiation, it consists of the two parts, direct radiation and diffuse radiation. Direct radiations, they come directly from the sun, and when we stand up in the sun, then it casts the shadow. Diffuse radiation, they are also called as the sky radiation. They reach on the earth after scattering by molecules in the atmosphere. They don't cause the shadow. So exactly the global solar radiation means the radiation absorbed by the atmosphere, that is ozone, water vapor and cloud, and the radiation absorbed by the Earth's surface plus the radiation reflected. This total comes to be called as the global solar radiation. So to understand about the solar radiation, this is the total, means how much of the solar radiation is coming. We add up all these three. Now next is the albedo. The term albedo is usually defined as the fraction or the percent of the reflected solar radiation from the surface to incoming solar radiation. So albedo is defined as the ratio of reflected radiation to the total incident radiation. The albedo of the whole Earth and the atmospheric system approximates 35%. The albedo of the crop surface ranges between 23 to 30%. So study of the albedo is very important, because it indicates to us that how much of the total solar radiation coming on the Earth's surface is exactly going back. Now next is the greenhouse effect, because the gases, namely water vapor, carbon dioxide and ozone, allows the solar radiations categorized as solar short waves to pass through the atmosphere towards the earth and not allowed to escape the long waves radiations from the earth. It is known as the greenhouse effect. This heat returning behavior is similar to the roofed glass or the greenhouse used for experiment. The mean temperature of earth is 15 degrees centigrade. Since long and is maintained by the greenhouse effect. Because we are studying here the solar radiation, so long waves radiation which are being emitted by the earth, they are being trapped, and because of this trapping there is enhancement in the temperature of the earth's surface, and this is known as the greenhouse effect. Now next is the radiation balance or the net radiation. The balance of energy after gain and loss of the both short wave and the long wave radiation fluxes is known as net radiation. Quantification of radiation budget. For this, when cloudiness is average, the absorption of the solar radiation by the earth's surface is about 43%, and by atmosphere it is about 22%, and about 35% is reflected back into the space. So this is about the albedo, because in albedo the earth is reflecting back about 35% of the total solar radiation that comes on the earth's surface. Now the factors affecting solar radiations, the distance from the sun, duration of daily sunlight period, solar elevation and inclinations of the solar rays to horizon, then transparency of atmosphere towards heat radiation, then output of the solar radiation. These are the different factors which affect the quantity of solar radiation that is coming on the earth's surface. So what is the distance, what is the elevation, how much of the solar radiation is being emitted from the sun. Now next is about the solar radiations of the major interest to the agriculture. We know that solar radiation comes in terms of the different electromagnetic waves. So this graph shows that in different individual electric vector, the solar radiation is coming toward the earth's surface and in a particular direction of propagation. So these elevations are known as the individual electric vector. The distance between these two peaks is known as the lambda, and it is called as the wavelength. In the second diagram, that is the electromagnetic spectrum on logarithmic wavelength and frequency scales, we can see that there are gamma rays, ultraviolet rays, infrared rays, then radio waves, and then electric waves. So towards the lower side it is the gamma rays, and toward the higher side it is the electric waves. This is total electromagnetic spectrum. If we want to understand about the solar radiation, it is necessary to understand about their wavelength. Significance of radiation in agriculture. It provides the necessary energy for all phenomena concerning biomass production. Photosynthetically active radiations are the real source of energy for photosynthesis processes. It also provides the energy for the physical processes taking place in plant, soil and atmosphere. It conditions the distribution of temperature and hence crop distribution on the earth's surface. We all know that light is the sole source of all activities with respect to the plant and agriculture, and not only for the photosynthesis but so many processes in the soil, in the plant and even in the atmosphere, they are being governed by the solar radiation. Now next is the atmospheric temperature. The degree of hotness is known as temperature. Temperature is the most important variable of controlling growth and development of plant and animal life on the earth. The most of the weather elements are dependent on it directly or indirectly. The variation in air temperature basically results into air motion so as to equalize the energy content of the different regions of the earth. With respect to the agriculture, both environmental and soil temperature are important. We all know the importance of atmospheric temperature, and it is necessary especially for maintaining so many activities in soil, plant and in the atmospheric system. Now next is the quantification of atmospheric temperature. For this purpose, we generally quantify the temperature in the form of maximum temperature, minimum temperature, average temperature and the mean daily temperature. The maximum temperature, it is the highest temperature attained by the atmosphere in diurnal variation. Minimum temperature is the lowest temperature attained by the atmosphere in diurnal variation, while average temperature, it represents the average temperature condition of the atmosphere during 24 hours of the day. The mean daily temperature, it refers to the average of 24 values of hourly temperature observed during that day. When hourly temperature record is not available, it is computed by taking average of maximum and minimum for the day. So this is about the how we can quantify the temperature. Either it may be maximum, minimum, it may be average, or it may be mean daily average. The temperature variation, air temperature at any place depends upon location, time and altitude. On this basis, it is classified as periodic variation, horizontal variation and vertical variation. To study about the atmospheric temperature, it is necessary to know about the variations, and it may be periodic, it may be horizontal, it may be vertical. Periodic variation, the temperature continuously changes according to period or duration during a day, week, month, year or any period, and this change is called periodic temperature variation. Periodic temperature variations are of two types: annual temperature variation or annual temperature cycle, diurnal temperature variation or daily temperature cycle. We know that temperature variation can be either it may be on the basis of whole year, that is annual, or it may be periodic, it may be for a certain period of the time. Annual temperature variation, the annual temperature variation gives rise to seasons, that is the summer and the winter. It reflects the daily increase in insolation from midwinter to the midsummer and decrease in same from midsummer to the midwinter. In the northern hemisphere, winter minimum occurs in January and summer maximum in July, and vice versa in the southern hemisphere. The smaller range occurs near equator and largest in latitudes. So we all understand that annually there is a lot of difference or variation in the temperature. In summer it is high, in winter it is low, and similarly it also varies from the what is the exact latitude where we are observing the data. Diurnal temperature variation, from the sunrise, sun energy is continuously supplied and the temperature continuously rises, recording maximum at the 2 to 4 p.m. Though the maximum amount of solar radiation is received at the solar noon, that is exactly 12 noon, this delay in occurrence of maximum temperature is caused by gradual heating of the air by convective heat transfer from the ground, which is known as thermal inertia. Similarly, minimum air temperature occurs shortly before sunrise due to lag in transfer of heat from the surface to the air or space. So within the day there is a variation in the temperature, and we all know in the daytime, at the noon time up to the 4 ppm the temperature increases, and similarly it goes down in the evening, and it is because of the transfer of the heat from the atmosphere to the soil and it heats up to the air. The next is the horizontal temperature variation. The rate of change of temperature with a horizontal distance is known as temperature gradient. Maximum solar energy is received in equatorial region, and therefore highest temperatures are observed in equatorial region. As the latitude increases, the solar energy received on the earth correspondingly decreases, and so also temperature decreases with increase in latitude being lowest on the pole. Isotherm, it is defined as the line on the weather map joining the places of the equal temperature. So we know that horizontal temperature variation is also important, and it varies from the distance from the equator and according to the latitude where we are standing. The next is the vertical temperature variation. It varies according to the layers of the atmosphere. The first is the troposphere. Temperature decreases from 15 degrees centigrade at Earth's surface up to minus 60 degrees centigrade at 11 kilometer height, while in case of stratosphere, the temperature increases from minus 60 degrees centigrade to 0 degrees centigrade at 50 kilometer height, while in case of mesosphere, the temperature fall and reaches about minus 90 degrees centigrade at 80 kilometer height. In the case of thermosphere, temperature increases again due to the absorption of the solar radiation by atomic oxygen, and it rises up to the 950 degrees centigrade at 350 kilometer height and 1700 degrees centigrade at undefined upper limit. So as the elevation in the sky increases, and depending upon the layer of the atmosphere, there is a variation in the temperature. it increases, then again it decreases, but finally in the last layer the highest temperature is reached. Factors affecting the air temperature, it varies according to the latitude, altitude, season, distribution of land and water, topography, ocean currents, winds, clouds and rains, color of the soil, slope of the soil, forest and vegetation. So there are different factors which affect the soil temperature, and they are related to the topography, physiography and the environmental variables. Variations of soil temperature. There are two types of variation in soil temperature. One is daily variation of soil temperature and another is seasonal variation of soil temperature. In case of daily variation of soil temperature, at 50 centimeter depth the change exceeds 10 degrees centigrade, while in the soil at 20 centimeter depth the change is less, and at 80 centimeter depth diurnal changes are practically nil. In case of seasonal variation of soil temperature, in winter the depth to which the soil freezes depends on the duration and severance of the winter, while in case of summer the soil temperature variations are much more than winter in tropics and subtropics. With respect to the change in the temperature, it is also necessary to know about the variations in the soil temperature, and at the surface level there are much changes in the soil temperature, but as and when we go at the deeper layer the changes are less. Then measurement of temperature. Temperature is measured either in Fahrenheit or Celsius or in Kelvin units, and the instruments are: for maximum thermometer, it is used to measure the highest temperature attained during the day. It is filled up with the mercury. Minimum thermometer is used to measure the lowest temperature reached on a day. It is filled with the alcohol. Soil thermometer is a mercury thermometer and is used to measure the temperature attaining during the day. The thermocouples are also used for measuring soil temperature, and they are of two types: thermoelectric and thermoresistance. Again, there is an instrument, thermograph. It is a mechanical device to record air temperature continuously. So measurement of the temperature can be done by the different instruments, and thermometers are the important instrument for that purpose. Now the instruments used for the measurement of solar radiation, and the instruments are the Campbell-Stokes sunshine recorder. It is used for recording the duration of bright sunshine. Spectral pyrheliometer for measuring direct solar radiation in broad spectral band. Solarimeter to measure global, diffused and direct radiation. Pyranometer for field measurement of the global solar radiation, natural sunlight and reflected solar radiation. Net radiometer or net pyrheliometer, it is used to measure overall net radiation. Albedometer, reflected net radiation or solar radiation from crop and other surfaces are measured by this instrument. The next is the quantum sensor. It measures the photosynthetically active radiation in the range of 400 to 700 nanometer. While the lux meter is used to measure intensity of the radiation. So to measure the different types of the solar radiation, there are different types of the instruments. Then types of the sunshine cards. The study of the sunshine card is very necessary because it is widely used in the measurement of the sunshine duration. There are three types of the cards available for measuring bright sunshine. First is the long curved cards. It is also called as the summer cards, and these are used from 12th April to the 2nd September. These cards are introduced through the bottom or the lower groove. Short curved cards, also called as the winter cards, and are used from 15th October to the end of the February. These are inserted into the top or the upper groove. Straight cards, these cards are used when day and night lengths are equal, from 1st March to the 11th April and 3rd September to the 14th October. These are inserted in the middle groove. So to measure the sunshine hours, the different cards are used, and they may be the short, long or the different types of the cards. The next is about the evaporation. Evaporation is a physical process in which water escapes from the surface into the atmosphere in the gaseous state. The rate of evaporation is expressed in depth of water lost in a unit time, that is in the millimeters per day. Evaporation from a surface is influenced not only by environmental factors but also by the depth, the size and the state of evaporating surface and surroundings, etc. So, to understand the different weather variables, it is necessary to understand about the evaporation, because the sun energy is responsible for the evaporation of the water from the earth's surface. Measurement of evaporation. The most commonly used evaporimeter in all the meteorological observation is the United States Weather Bureau Class A open pan evaporimeter. It operates on the principle that the amount of water lost by evaporation from the free water surface in the pan at any given interval of time is measured by adding known quantities of water to the pan and bringing it to the original level. This is an instrument used to measure the amount of water lost by evaporation per unit area at a given interval of the time. You can see in this particular diagram that it is a US WB class A pan evaporimeter. It consists of, there is a tank, there is a soil well, there is a thermometer, there is a wire mesh and there is a hook gauge, and it is all kept on the wooden platform, and there is a measuring jar to measure the water and power the water into this tank. So, for the measurement of the evaporation, the most important instrument is the USWB pan evaporimeter, and it by measuring the water which we are pouring into this tank, we can measure the water, how much of the water has evaporated. Hello viewers, in this part of the programs we have discussed about the solar insolation, temperature and the different factors which affect the solar radiation and temperature. We have learned about the evaporation and what is the basic meaning of the evaporation, and the instrument used for the measurement of the evaporation, and similarly we have learned about the different aspect of the temperature, and it includes both air temperature and soil temperature as well as the factors affecting them and the different instruments which are used for the measurement of the temperature. We have learned about the different aspects of the solar radiation in terms of their different electromagnetic waves, and we have also learned that how much the solar radiation is exactly coming on the earth's surface and what is its quantity, and I hope that you might have enjoyed the lecture. Thank you.